One useful way of being able to describe motion is through the use of motion graphs. Take a little clip of these animals just running back and forth here at the zoo. How would you describe their motion? It's pretty easy if you use words, but how would you quantify it? The best way to quantify their motion is by doing a motion graph. By graphing the animal's motion, you can get a clear picture of exactly what's going on as they're moving back and forth in their cage. To begin, let's look at some just general position versus time graphs, as well as velocity versus time graphs, to see what those kinds of graphs can tell us about how an object is moving. Let's start with our position versus time graphs. Okay, take a look at the graph on your screen. What kind of information does it tell you? If we focus just on the shape of the graph, what it's telling us is that an object is moving with a constant velocity. Every second that goes by, our position has changed by a value of 10 meters. Compare that graph to the one on the right. What's different about the two? Hopefully you noticed that on the graph on the right, we are no longer covering the same amount of distance every second that goes by. What that means is that we are accelerating. On a position versus time graph, if we have a constant slope, as indicated by this graph on the left, that indicates a constant velocity. If our slope changes, that indicates some kind of an acceleration. Now, how about this one? This actually represents two different things going on. From 0 to 5 seconds, or this first part of the graph, our object is moving. And it's moving at a constant rate because it has a constant slope. But what do you notice is going on with the graph when it hits 5 seconds? If we look at the y-axis, we're stuck at a value of 25 meters. And we stay at that position for the remainder of the graph. What that's showing us is that we have no change in position. So in other words, the object is stopped. Anytime you have a plateau on a position versus time graph, that indicates no change in displacement, okay, or no change in our position. No matter what though, if I have a position versus time graph, the slope is giving us information about the velocity of the object. Let's compare these two graphs side by side. Both of them are a position versus time graph, and both of them show a constant velocity because we have a nice straight line, even slope. This graph on the left, though, indicates the object is moving relatively fast. The graph on the right is showing that the object is moving relatively slow. The steeper the slope, as indicated by the graph on the left, the faster the object is moving. How about these two? This time, the graph on the left is showing a slower velocity. The graph on the right is showing a faster velocity. The way that we can tell slow versus fast, again, is by how steep the slope of the line is. We'll compare these two graphs kind of together. The top graph is indicating movement to the right position, as indicated by a positive slope. The two graphs on the bottom are indicating that the object is moving to the left. We're getting a negative slope. So not only does the slope tell us how fast or slow something is going, it also can indicate the direction if I pay attention to how that line is changing on my y-axis. Let's now take a look at this graph. Okay, what does the shape of this graph tell us? Well, notice how we no longer have a constant slope value. I start out with a relatively shallow slope, and then it gradually gets steeper and steeper and steeper. So the position I cover every second of time that goes by keeps increasing. That means we are speeding up. Contrast that with the graph on the left. We start out with a relatively steep slope, and it gradually kind of gets a little bit more shallow. That's letting us know that we are slowing down. Both of these graphs, however, are showing us that it's accelerating. A curved position versus time graph indicates acceleration. Okay, let's take a look at another type of graph, a velocity versus time graph. Here I'm going to plot velocity on the y-axis as a function of time on the x-axis. What does this graph tell us? Well, if we focus on how the line is going, it's at a constant 10 meters per second. This graph is showing us that we have a constant velocity. What if the graph looked like this? How is that different? Notice how we still have a constant velocity, but this time it's in the negative direction. Positives and negatives are used to indicate direction. Typically, a positive velocity would indicate something is moving to the right, or something is moving upwards, or if we use our cardinal directions, we could talk about north and east. Something with a negative velocity, we could say is moving to the left, or we could say it's moving down, we could say it's moving west, or we could say it's moving south. So again, positives and negatives are used to indicate direction. Okay, well, what is this graph showing us? It's still a velocity versus time graph, but notice how now we have a velocity that's changing. We're increasing our velocity by an increment of 10 meters per second every second that goes by. If my velocity is changing, that means the object is accelerating. So on a velocity versus time graph, you have to be a little bit careful about the direction of the line. How would we show that an object was stopped? Take a guess. One thing that you need to be careful of, okay, is those slopes of the lines. Notice how these two graphs are both showing objects moving with a positive velocity. Both of those lines are above the 0 point on the y-axis. The graph on the left shows that we're going from a slower speed to a faster speed, but still in the positive direction. The graph on the right indicates that I'm going from a high speed down to a lower speed, okay, but still in the positive direction. The positive and the negatives is what really differentiates velocity from speed. This new set of graphs is indicating the objects are moving with a negative velocity. It's a negative velocity because both lines are on this negative part of the y-axis. The graph on the left shows us going from a high speed to a low speed, but still in that negative or that leftward direction. The graph on the right shows we're going from a low speed to a high speed, but still moving to the left or a negative direction. When analyzing velocity versus time graphs, you have to be very careful about the slope. The graph on the left, both lines are showing an increase in speed. We're going from a low number to a high number, even in the negative direction. We're going from a low number to a high number. These graphs on the right, however, both lines are showing a decrease in speed. We're going from a high number to a low number. On the bottom, they're in the negative velocity. We're going from a high number to a low number. What you need to be careful of is how you talk about acceleration. These two graphs highlighted right now are both showing a positive acceleration. These two graphs highlighted in green are both showing a negative acceleration. Look at your equation for acceleration below. Remember, an acceleration means a change in velocity over time. So we're looking at a final velocity minus an initial velocity over the amount of time that goes by. Now would be a good time to hit pause, put in the numbers, and prove it to yourself. If we have a well-labeled graph, we can get a lot of quantitative information from it. If I look at this position versus time graph, if I calculate the slope, I can figure out how fast the object is traveling. Velocity is just given as position over time, so I'm going to take my rise over my run to get that value. Please find your calculators and calculate how fast this object is traveling.